Hi to everyone. Today I present you the Monroe mechanical calculator. I have here 4 of them. They're all basically the same. The inside is the same in each one of them. I open them up and they're all the same. It's just the time, they come from a different decade. So I guess that one is the oldest one, a little bit still nice colors. 1930s I would guess. This is a little bit later, so 1940s. Still has a little bit of that style, but already the colors are not the same. And then we have 1950s, as you can see, very worker style calculator, gray color, everything. So how does it work? I just can insert any number and I turn the crank once and it will appear here. Then I insert the second number I want to add to the first number, and here I have the total. This lever helps me, is needed to reset both counters. So if I turn one way, I reset the counter register. If I turn the other way, I reset the output register. I have also these 2 buttons. If I press the first one like this, each time I do a turn, the buttons jump up. If I press the other one and I enter a number, the buttons remain in the same position. So I will use this button when I have to do sums and addition and subtractions, and I will use this number when I do multiplication. Okay, so this was for the sum. If I have to do a subtraction, I have to insert the number with a plus turn first into the output register. At this point, I can input the second number I want to subtract, and I turn the crank the other way. And here I will have the subtraction. Multiplication, as we said before, is a repeated addition. So if I have to do 5,456 by 47, I turn 7 times the crank. Now I have to put the R. That's the reason why I need that one. So 4,567. I took by 47. So I turn 7 times. 2, 3, 4, 5, 6, 7. I move the carriage and I turn another 4 times. 1, 2, 3, 4. And here it says 4,567 by 47 is 214,649. If I want to do it by 347, I move the carriage 1 more position and I do another 3 turns. 1, 2, 3. And so I obtain the result of 1,584,749. As you can see, it really makes multiplication quick and easy. For division, I move the carriage completely to the right. I can also do it this way. I input my number, 987. I have to do a plus operation first, so it appears in the output register. I reset the counter. Now I input the number I want to divide by, which is 610. I will not have to push anything on the 0 because it's already a 0. So I actually just input 61. And this also helps the children understand that whatever you do, if you do divided by 61, by 610, by 6,100, by 61,000, you always obtain the same numbers. It's just the comma that changes, the position of the comma. So now I subtract until the machine tells me I've gone underflow. That means I've gone below 0. One time. Ping. Okay. I go 1 turn back and again. Oh, already. Okay, so the bell doesn't always ring if you don't do it with a certain power. But the good thing is that if you realize you've gone too far, you can just turn the other way around until you're again above 0. And this is the result, which is 1.6180327, and that's a good approximation of the golden number. Okay, let's go for the last number, the last operation, which is a square root. I have already prepared one, which is a complicated one, 8-digit number, 3184 3449. Okay, I input the number once with a plus operation, 31843449. I reset the counter register. Now I count the blocks of 2 digits starting from the right, so 2, 4, 6. That means that's the last block. That means I have to start my subtraction of odd numbers from the column of the 1. So I start here, 1, 3, 5, 7, 9, 11. That's too much, so I put it to 10, and I start on the next column. 1, 3, 5, 7, 9. Next is 11, 3. I've gone too far. I put it on 2. I go to the next column. 1, 3, 5, 7, 9. Gone too far. I put it on the 8, and I go on the last column. 1, 3, 5. Okay, I've gone to 0, and my result is 5,643. Please refer to my other video where I explain why you have to do this sequence of operations, but it's just to show that within less than a minute I could do a square root of an 8-digit number. So that really, I mean, once you are practical with it, I have students doing it in 30 seconds. They're really fast, and it's really not complicated once you learn how to do it. It looks a little bit complicated like this, but it's actually repetitive actions. You always do the same. Okay, that would be about it. Thank you very much for listening, and have a nice day. Bye. Vai con la prossima. Te l'ha detto? 1, 4, 2, 4, 3, 0, 7, 6. Bravissimo.